Math 3, Unit 1, Section 1. So today we're talking about parent graphs. What we mean by that is, as we go through this, we're going to kind of look at how graphs start, and then throughout this unit we're going to be shifting them and rotating them and moving them around. But it's important to understand where they start before they start moving. Okay? So, linear. What's another word that people use for something like this besides linear? What kind of graph does it make? A line. You guys are super intelligent already. Okay, a line. And so this is our standard equation for a line. The way that we're going to end up rewriting this for right now is we're going to write this as y equals 2/3 x plus 0 in parentheses plus 0. Now the reason why we're doing this is that this is giving us our starting point. Whatever's in parentheses, when you end up taking that value out, you would set this equal to 0 and find that the value is 0. If this had said something like x plus 1 in there, and let's say there was a plus 3 here, when you set that equal to 0, you would end up getting a -1 for x, and then this value at the end is a +3, okay? And that would give us a starting point. So for each of these, we're gonna rewrite them in this form to remind us that our starting point for this one is at 0, 0, okay? And so if we go to 0, 0 and make a point, we know that's where we're starting from. Is there anything else that you know about this type of equation? No? Okay, so if you ever have an equation and you're like, I have no idea what to do next, you can always plug in values, okay? And so I'm going to go back to this equation and we're just going to plug in a couple values because we want to have 3 points in order to graph a line, okay? And so I'm going to go ahead and write this as y equals 2/3. And what would be a good value to choose? Now, before you say something, notice that you have a fraction here. So what kind of value could I use that would end up eliminating the fraction? I heard someone say it, 3. 3 would be a good choice, okay? Because when you're multiplying this by 3, you cannot write that as like 3/1. And the 3's can reduce, right? And so you end up getting what? Just 2. Because when those reduce, they become 1, and 2 times 1 is 2. And so as an ordered pair, the value I plugged in was what value for x? 3, and the y value was 2 once I simplified. Okay. And so on our graph, we're going to go right 1, 2, 3, up 2, and make a point. And it's a good idea to always use a positive value and then also a negative value. And so since I use +3, why don't we go ahead and use -3? Good. So y equals 2/3 times -3. And so again, we can reduce. So the 3's reduce, and this makes this a negative what? 1. And 2 times -1 is -2. Is anybody confused by that? Yes? So if I were to rewrite this out, here, I'm just going to kind of write here to the sides. If you have 2/3 times a -3, you can always put that over 1. Okay? So we're multiplying by -3. If cross-reducing or reducing here confuses you, you can multiply tops to the tops, bottoms to the bottoms, or numerators, denominators, right? And so you can multiply and get -6/2. And then -6/2 reduces to be what? -3. You can put -3/1, but we normally don't write things with over 1. Okay? Does that help out a little bit there? Okay. So as an ordered pair, then what would be this ordered pair? What value did I plug in? -3, and then, very good. So left 1, 2, 3, and down 2. And then we draw our line. Okay, any questions? Now, if on any of these things you notice something or you notice a shortcut we could have used instead, feel free to share it, and then we'll kind of talk through that. Okay, next one. So I'm going to first rewrite this with the zeros. So it's y equals 2, parenthesis, x plus 0 squared plus 0. So these two equations are the same. I just want us to start looking at it like this because this is how we're going to see most of our equations. Not all equations start at 0, 0. So this starting point, but on this one it's also called a vertex. The vertex is going to be what? 0, 0. Very good. So we're going to make our point at 0, 0. Okay, so from there, we're going to plug in values, just like we did before, okay? And so, because there isn't a fraction, I'm going to use 1 and negative 1, okay? So we're going to use our original equation. So we have y equals 2, and then I'm going to plug in 1 for x, okay? So I'm going to have a parenthesis and then 1 squared. Does everybody understand where I've got these numbers from? And could I have chosen a different number? Yeah. So 1's just easy, it's small, it makes my life a little simpler. Okay, what is 1 squared? 1. So I'm just going to cross out 1 squared and I'm going to write a 1 here to save room. And then I end up with 2 times 1, which is 2. Okay, so what is this ordered pair? What value did I plug in for x? 1, and then the y value was 2. So my second point now that I'm going to go is write 1 up 2. Okay, so now we're going to use another value, but we want to use a negative. And so I'm going to plug in a, good, negative 1. Negative 1 squared. So what's negative 1 times negative 1? Very good. And 2 times 1 is 2. So what was the x value I just plugged in? Negative 1, and the y value was 2. Very good. So we go negative 1 up 2, make our point. And a quadratic function is where you have a squared term. And this type of graph is a U-shape, good, which sometimes people call that also a what? Very good, parabola. And so we're going to make that U-shaped graph. And there we go. Okay, questions up to this point? No? Okay. This next one, linear absolute value. So notice it says linear. Notice also that our exponents here are 1. And with a line, your exponents are 1s. Okay, and this is linear. It's a type of line. Does anybody know what an absolute value graph looks like? Not sure yet? Okay. What? It is positive. Very good. So, because absolute value means that whatever's inside is always coming out positive, right? So we're going to have to see what this graph looks like here. We'll play around with it. But to start, I want us to write the equation again. So y equals 2/3. And then inside the absolute value, I'm going to write x plus 0. And at the end, I have plus 0. What will be my starting point on this one? 0, 0. This one is also called a vertex. Okay? A vertex is when you're like changing a graph. It changes from one direction to another. Okay? So we have this. If we're not sure what's happened or what's happening or how to graph this, what should we always do? Plug in a value for x, right? So because this is 2/3, what would be a good value to plug in? Very good. So y equals 2/3, and I'm going to take the absolute value of 3. What is the absolute value of 3?
3.
Very good. So I'm just going to rewrite this now as 2/3 times 3, because I took it out of the absolute value and it's positive when it comes out. Okay, what will happen with this when I multiply and simplify? What does it equal? 2. And so again, these 3's can cancel out. If that doesn't make sense, you could end up getting 6/3, which ends up reducing to be 2. And so what is that ordered pair?
3, 2.
Very good. 3, 2. So we're going to go right 1, 2, 3, up 2. So now we're going to use a negative value. So same equation, y equals 2/3, except for this time I'm using a -3 for x. What is the absolute value of -3? Very good. So I have 2/3 times 3 again, because it came out of the absolute value. And that reduces and equals what? 2. So what is my ordered pair on this problem? -3, 2. Very good. So we go -3 up +2. And so what happens is that this ends up making a V-shaped graph. Good morning, Mrs. Hart. Thank you. This is Mrs. Hart, she's one of our learning directors on campus.
Right, you should be so happy to see me.
Exactly. She is the one that helps you feel safe.
Yeah, something like that.
Yes.
Also make you worry about your birthday. Maybe you said this out there with you.
Thank you. So, if you think about it, if this was your regular line, which you know how right here in the first one, we had the y is 2/3 x. Wherever this line is negative, if you were to take the absolute value, it just flips it up in order to make it positive. And so that's why this is a V shape, because everything that would have been going down gets flipped up and has now become positive. Okay, and so all absolute, linear absolute value graphs, they are always in the shape of a V. Okay, questions there? Okay, exponential. So for the exponential graph, we're just going to start plugging in values. Okay, and oftentimes with the exponential graph, for some reason, I like to make a t-chart. So I'm going to do that with x and y. And we're going to start by plugging in the value of 0. And so when I plug in 0 for x, 2 to the 0 power equals what? Half of you said it correct, half of you not. Okay, so 2 to the 0 power is 1. Anything to the 0 power is 1. So as an ordered pair, this is 0, 1. So for exponential graphs, how all of our other parent graphs, the starting point was at 0, 0. On exponential graphs, your starting point is always at 0, 1. Okay, so now we're going to plug in a couple more values. So let's plug in 1. So 2 to the first power, what does 2 to the first power equal? 2. So this ordered pair is 1, 2. So we go right 1, up 2, make our point. Okay, what other values should I choose? I think we should choose a negative at least. So -1. And so 2 to the -1 power. Do you guys remember what happens when you have a negative exponent? How do you make that exponent positive? Very good. So I'm going to write this here to the side here for just a minute. So if we have 2 to the negative first power, you can think of this number as being over 1. In order to change a negative exponent to a positive, you change the side of the fraction that it's on. So that means this would come to the denominator, and so you'd end up with 2 to the first in the denominator, and if nothing is on top, that's a 1. And so this ends up becoming 1/2. because 2 to the first power is just 2. So we get 1/2. So this ordered pair is -1, comma, 1/2. Do you think there is a value that I could plug in here that would end up making y equal to 0? So we plugged in 0 for x and it became 1, right? When I plug in a negative value, it became a fraction. So what happens is it doesn't matter what value I plug in for x, it will never equal 0. And so what that means is that there is an asymptote here at 0. And what an asymptote is that the graph will get really, 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 really close to that line, but it will never actually touch the line. Okay? I always think of asymptotes almost like magnets. And you know how if you have 2 magnets and you try to put them together, but they're like the positive positives, like they just kind of keep pushing away a little bit? And so that's how an asymptote is. Like you can try to get it close to it, but it won't ever actually touch it or connect to it. Okay? And so down here at the bottom, we're going to write, I'm just going to abbreviate ASY for asymptote. Does anybody know what that line is? How you would write that line, the equation for the asymptote? Very close. Good job. Y equals 0. So it's going through every x value, but it's only going through the point at y equals 0. So all horizontal lines are y equals, where your vertical lines are x equals. Okay. Do you have any questions on those? No? Okay. I'm going to try to get through these 4. We're going to see what happens. Okay, we might go a little bit faster, but only if we can handle it. Okay. So, just like before, I want us to rewrite this equation. So we're going to write that as y equals -3, parenthesis, x plus 0, plus 0. What's my starting point? Very good. 0, 0. So we go here to 0, 0, make our point. Does anybody know a shortcut for this type of equation instead of plugging in points? Use what? How do I use -3? Very good. Do you remember what that's called? Very good. This value right here we know is called the slope, which gives us our rise over run. Do you guys remember that? And so we can plug in points. If you forget that, plug in values and draw your line. But if you remember that from this point, that means the slope is -3 over 1. So we go down 1, 2, 3, right 1, and make a point. How could I get a point going in the opposite direction? What would I do? Very good. So you can also go +1, 2, 3, but then you have to go left or -1. And just in case you guys have forgotten, remember that going to the right is positive, left is negative, down is negative, up is positive. Also remember that this is your x-axis and up and down is your y-axis. Okay, any questions? All right. Okay, next equation. Y equals -3, parentheses, x plus 0 squared plus 0. So what will be my vertex or starting point on this equation? Very good. So vertex is 0, 0. And then let's go ahead and plug in points. So we have y equals -3, and I'm going to start with plugging in a +1 squared. What's 1 squared? 1, good. So -3 times 1 equals -3. Good. So what is that ordered pair? 1, -3. So right 1, and then I'm going down 3. So then we want to plug in a negative value. We have y equals negative 3 times negative 1 squared. What is negative 1 squared? So negative 3 times 1 equals negative 3 again. So what's that ordered pair though? Negative 1, negative 3, because we plugged in negative 1 that time. So negative 1 down, 1, 2, 3, and this one goes down. Now what do you notice? What is the difference between the top graph right here and the bottom graph right here? What are some differences? Good, and the positive graphs curve up and the negative graphs curve down. Good. Okay, we are going to actually stop there.